Hello guys, it's Bleej from Bold Stroke Adventures. Today we'll talk about a different kind of adventure. It's not on the foot. Oh, it is in one way, but we'll talk about chemistry for a change. Chemistry or science adventure. You're probably wondering, what did I just do? And if I would ask you, do you have any idea what is this? You might have idea, maybe not. I'm gonna help you out. This, what's behind me, it's a limestone. What is the limestone? Well, limestone is the type of the sedimentary stone created millions of years ago, when this was ancient sea. This is actually, the riverbed. It's completely dry now because it's summer, but even better, I got easier access to all this limestone. It was made by organic and plant life, ocean life, sea life, shells and fish and all those things a million years ago, through the process of fusing together, pressure and aging, and we end up with all this limestone. Now, why would we talk about limestone, and what is that got to do anything with the chemistry? Well, limestone is very actually it's very unique in one way, because it's a plain rock, plain stone. But something will happen if you put this rock or stone through the process of thermal decomposition. What is the thermal decomposition? It's exposing a substance or element to the heat. And when it's exposed to the heat, chemical reactions happen, and things will change their properties. Now, I already made something before I got here. Of course, I'm not going to be cooking any limestone here, but I'm going to show you a few examples what is actually happening with the limestone. So this is everything is made from the same piece. I just broke piece in a few different segments. So this is the limestone, plain limestone. Doesn't really have any smell, nothing special. If you take a close look into limestone, you might see some fossils, shells, calcium deposits. Not more than that. Now remember this. We go to the next step. Thermal decomposition. This is the same limestone. Absolutely the same limestone. It's completely white. But what happened? Well, if you expose this limestone to the cooking process, this specific one I had when we had a bonfire, I had this in the fire all night, and it cooked all night. And when this limestone was exposed to the thermal decomposition and extreme heat over a period of a long time, then we have something that I mentioned at the beginning, chemistry. It's incredible science. I'm amazed by the chemistry. I love chemistry, and through the process of the heating this limestone, things will start changing. And at the end of the process, this limestone will be completely white. After this piece cools down, If you try to smell it now, it's not like the piece I had in my hand previously. Now it does have a smell. It has very chemical smell, like a chemical substance. And this is very interesting, because what we just done, we made a quicklime. Now this quicklime, it's not just a regular stone anymore. It's very reactive. When you apply water to the quicklime, it's gonna start pretty much boiling. It will release gas. It will start falling apart into pieces, and it will create a lot of heat, potentially 150 Celsius degrees. It's gonna be very hot. If you ever do that, you need the actual gloves. And the last stage, which is actually amazing, you can actually grind this into a powder. And this limestone quicklime powder is actually quite amazing. This powder, look at the powder. This powder, again, when mixed with water, it is ancient plaster for construction. What we're using today is the same thing. Once you mix that with the water, it's gonna become like a sludge, like a Play-Doh. You can mold it and you can use that as a plaster like thousands of years ago. And that's pretty cool to me. Finally, when it's dry, it's gonna be hard like a rock. So you can put rocks together, this plaster in between, and you can make a castle. So that's pretty cool, how you end up from the simple limestone. By the cooking process, you change composition, you can turn that into a powder, it became reactive with the water, and you pretty much create a plaster. I think that's pretty cool. Now, to mention something that you might didn't know. When we cooking lime, carbon plays a very important role to the thermal decomposition process. Now, carbon itself, do we know what is the carbon? Well, carbon is pretty much the most important element on the earth. It's very unique, and it's essential for the all life on the earth. Without carbon, there is no life on the earth. It's fourth most abundant element in the universe, of course after hydrogen and helium, but on planet Earth it's essential, and there would be no life without carbon. Even in this simple process, got nothing to do with life, carbon plays a role. Now, when I'm talking about essential for the life on the Earth, just gonna give you a couple of simple examples. Carbon itself bonds very easily with other elements. If you go to the periodical table of elements, you can see nice C. It's gonna be right on the right hand side, right on the top. It's gonna be right next to the hydrogen and nitrogen. And like I said, no carbon, no life on the earth. All this green stuff that you see around me, plants, they need carbon dioxide to live, and in return they will release oxygen that I need and everybody else, living things. We talk about humans, animals, they need oxygen to live. So it's like two sides of the coin. Also, carbon dioxide, I said it very easily, carbon bonds with other elements. carbon dioxide, also called as like greenhouse gas on planet Earth. It actually helping planet Earth to keep all heat from the sun close to the actual planet. If there was no carbon dioxide, there would be again no life on the Earth. So you see how amazing is this. We're going all the way through the limestone to the universe, and to the carbon. We go through some chemical elements, and it all became from the simple rock. It is amazing. It's very amazing to me, and this is just one element, how you can turn rock into something completely different. Bear in mind, another thing is that you can use limestone is you can actually create calcium carbide. Now this is something completely different, and it's more and more dangerous. I'm gonna explain how. I have to go a step back a little bit. If you heat up the wood without presence of oxygen, what will you get? You will get coal, which is more efficient and it will create more heat. If you apply the same process, thermal composition, to the coal, if you do the same thing to the coal you just did to the wood, you will get coke. What is the coke? It's not cocaine. We're talking about a step further from coal. Again, it's more efficient and it will create more heat than coal itself. By mixing limestone and coke, I just mentioned, those two elements, by mixing them together and heating them up to 2000 degrees Celsius over a period of time, they will bond together through the chemical process again. After process is done, what did you get? Well, you just got not quicklime, but you did get calcium carbide. If you didn't know, it's very important as well. Why it's important? Because by applying water to the calcium carbide, you know what you will get? You will get acetylene, straight acetylene from the rock. When we used to be kids, we knew places where we can get this already made, and if you spit on it a little bit, it will release acetylene. And acetylene itself is very flammable and explosive gas. If it's confined in the can or some other means with proper amount of oxygen, it will explode, and it will explode very dangerously. If you apply just water, you can actually set this calcium carbide rock on fire. It will burn as long as there is a source of water. As long as there is a source of water, there is a source of acetylene. So, you know, that's pretty neat. All these things in the nature, if you know how to put them together, you can get wild things. And that's why you have to respect chemistry. You need to know exactly what you're doing. And it could be pretty fun. So that's about all for me. I hope you actually did learn something today. I'm gonna actually continue my hike. I'm hiking today, and I'm gonna continue my hike through this riverbed because there is no water, so I can actually do that. Aiming for one beautiful waterfall, which I realize it's not gonna be a waterfall at all. It's just gonna be a big limestone wall. But anyway, I hope you like this video. Please subscribe, and I'll see you at the next adventure. Cheers.